My name is Matei Popa, and I'm a big data cloud architect and SysOps CD Solutions. This is me being your host here on the technical track. So I'll act also as your voice. As you probably saw already, you guys need to ask questions in the platform, and then I'll approve and I'll make sure that the speakers hear them. Um, then I would like to thank, in the name of V Solutions and Big Step, which are the two companies that are presenting the whole event. I'd like to thank, first of all, our partners, and then I'd like to thank Microsoft, Cognizant Softvision, ING Tech, Trencadis, also Google Cloud, MetalSoft, and Bucharest AI. These are the guys who made it all possible, so we get very interesting content for you guys. What else I'd like to say that I strongly encourage you to check out a Digital Expo during the breaks. We have a lot of surprises prepared for you. And we're going to continue right now with the next session with Victor. I would like to tell you to don't forget to switch to the next session each time the presenting one finishes because it's not automated.
Not only today, but on the long term, which is real-time AI, how to implement it, and some examples that I'm going to cover. In a few words, I'm going to share my slides right now, so you're able to see everything. Now, today we're going to cover everything that, let's say, Google Cloud is able to provide for you in the real-time AI area. We're going to discuss the issues and the motivation of such an approach, some architecture and specific customer solutions. The good thing about the solutions is that you can try it yourselves, and I'm going to show it to you in a few slides in a few moments. And on top of this, we're going to have, let's say, a surprise for you that I'm going to announce at the end so that it's clear enough how it can be approached and how you can do it. Okay. So let's start with the slides. This first example is about the public safety organization. It has a lot of security logs on a daily basis, tens of gigabytes. So you can imagine the amount of data that was running on a daily basis. As well as the important thing is that out of this amount of data, only a few thousand logs were high importance or actually of use to this organization. Most of the approach was a basis on heuristic and manual process, which meant that a lot of, let's say, steps could not be covered for all the data that was available there. And definitely there was a need for an unsupervised solution that could definitely identify easier the issues and how to approach them on the long term, especially with the growth of data that is going to be showing up more and more in the future. Another second example is about telecom. It's a fast-growing national telecom that had a lot of mobile traffic, and everyone can relate today what has happened in the last few months with more and more, let's say, both data as well as calls being taken on by telecom providers. And this specific organization was interested to address malware and security threats and how to easily identify patterns as fast as possible. And more important is to stop this kind of issues before they happen, or as fast as possible, especially with the new types of issues that were showing up. What they're trying to analyze was finding anomalies and acting on the sender-receiver traffic. Now, bearing these two examples in mind, we're going to go through the driving forces of specific real-time AI. And definitely for the real-time AI, the expectations are that it's a near human intelligence. It means that it's able to take, let's say, decisions on its own and mimic the human way of approaching it and the human brain. And most important is the second step, which means applying this logic on a large number of events, more than humans can possibly read, work with, and apply. So this would be the biggest advantage of real-time AI as an application. Now, when we talk about real time, definitely there are just a few systems in this world that are real time. We should be approaching it in near real time in a matter of seconds, sub-seconds, and so on. It's something that we can approach and definitely provide the solution and also the results, so that either it's being processed automatically or it's being sent to a human operator that will take the decision what to do with a specific situation. It's very important also to discuss the value of data. This chart is showing very nicely how, let's say, the biggest value of the data is as soon as an event happens. And shopping carts are something that everyone can relate to. So once a specific event, for instance, is happening on a web page, and you are able to take the decision and make, let's say, an offer, a suggestion, or identify that this person might be willing to buy something. If you take that action, then it means that you are making the peak of the value of that data. The more you go on, let's say, on the time scale, the less value you will have, until you would actually store it on a data warehouse solution, and you will be able to have this mountain of wisdom, as it's called here, that allows you to make decisions on the long term, which are related to planning, identifying patterns, solutions, and so on. And the approach is that most of the right area is being handled more or less with solutions today by a lot of customers, is how you drive this, let's say, logic, understanding, and behavior as close as possible to the event and when it's happening. So this is why streaming is important, and apply the AI as close as possible to the event happening. Now we have a few, let's say, needs that come up across industries. Two of them to be more specific. First of one is recommendation that comes in different shapes and needs. And the second one is anomaly and pattern detection. Starting with the first one, recommendations come in retail as cross-sell, upsell, offers, in media related to new types of services, video, songs, recommendations of any type. In telecom is pretty much similar with upsell and cross-sell, as well as new handsets or other hardware offers. For financial institutions, it's also related to insurance offers, account migration, and so on. So a lot of interesting things that should be done as fast as possible in terms of recommendation. The second area, which let's say puts together both anomaly and pattern detection. As you can see, it covers a lot of industries, and it is related to any type of theft, fraud. So you can think of a lot of issues that are showing up and need to be handled as fast as possible. And if possible, let's say prevented in terms of approach. Without further ado, let's jump to, let's say, real-time AI, which is covering the 3 points that I've just mentioned before, enabling machine learning models, which should mimic the human intelligence as close as possible, handling a large number of events, and in this case, we have the available pub/sub technology that can cover this quite easily. And most importantly is how you'd approach everything in near real time with the streaming analytics systems. GCP, Google Cloud Platform, has a comprehensive set of tools for training models. One of them that's very easy to be used specifically for people who are in the data warehouse and know SQL is the BigQuery ML, that allows you to easily, let's say, build models by using SQL logic. And this can be easily integrated with data flow in order to provide the logic and run it in near real time. Then the intelligence is built based on the ML models that come out of the box, as well as integration with, let's say, pre-built models from other open source technologies. The other approach is based on cloud AI with TensorFlow Extended. It's pretty much giving the flexibility to the people who are more, let's say, advanced in building models and are interested in specific types of approaches and they already have something built in TensorFlow and so on. And the approach is quite similar because it's easy to plug and play the models. You can even use some of the Google AI Hub models, approaches, flows that are already pre-built. You just need to customize them to your needs, and then build all the blocks in one place in order to consume it. Three areas can be approached, or let's say there are three flavors of it, as I would like to call it. Either you would use BigQuery ML with data flow in order to do the processing of the logic that you build in BigQuery with a machine learning there. So I was explaining that you can use BigQuery ML logic to build the models and then run them on data flow, and this would be the first approach of them. The second would be to use the Cloud AI platform, which is a bit more advanced in terms of how you can use it in, let's say, process on CPU, GPUs, as well as the breadth of models. Or for the most advanced users that want to have all the flexibility available there, it's the TensorFlow extended, again with data flow in order to have a processing done in very near real time. We mentioned at the beginning the public safety organization. Now it's time to also to introduce the solution and how we approached it. The solution was based on time series anomaly detection by using data flow and TensorFlow extended. It uses an LSTM encoder decoder in order to identify this kind of anomalies. And from 12 billions to a few thousands per day, this was the amount of data that was used in order to build it. The good thing about it is if you are actually curious to know how to use it, how to approach it, and you have the time or the eagerness to implement it, if you go to cloud.google.com/dataflow and you look for the real-time AI, you're going to be able to find the solution and, let's say, implement it on your premises. It composes of three building areas. Is the pre-processing, using BigQuery, data flow, and pushing everything in cloud storage so that it can be used. The model training, which starts from cloud storage where the time series are prepared, the Cloud AI platform that does the training, and then all this logic is stored on the cloud storage again, so that it can be used as a model in cloud data flow. And again, the flags, the anomalies that are identified are stored in cloud storage. And this composes of all the building blocks, the anomaly detection using LSTM as a solution. Getting back to the second example with the telecom, you remember that was a large amount of traffic. We had a lot of issues related to malware, security threats. And in this case, the approach was to use BigQuery ML and train a k-means cluster to identify anomalous situations, and also use DLP in order to, let's say, take out all the information that was going in the GDPR or PII area, so that it does not, let's say, interfere with any of the other regulations that this telecom had to cover. So let's show you how it was approached. It pretty much uses a k-means cluster, which is a traditional way of approaching it. The idea is how to push it as fast as possible in real time. And in this case, if there was more than 3 standard deviations further from the cluster that are identified, it was considered an anomaly. And in this case, it had to be investigated, stopped, or analyzed, and so on. So this telecom took the freedom to do specific tasks based on the anomalies that were identified. The architecture of it is based on getting the pre-processing and the features that need to be created. The second step is the model training, similar to the previous solution. And the last one is the anomaly detection per se. Starting with the events, these are handled by the pub/sub technology, then are pushed in data flow where the processing is happening, and using Cloud DLP in order to anonymize the data that was not useful for, let's say, the analytic process, and definitely all the PII data was not the intent of this approach. Now, also, let's say, other events were being used in order to have a real-time by using PubSub. And the logic that was created by using BigQuery ML was used in Dataflow in order to process everything together. Again, everything was sent to another stream in PubSub so that everything can be handled, let's say, further on by another application consuming this data. Again, this solution, you can find it on the cloud.google.com/dataflow by looking in the real-time AI area. Quite recently, a few months ago, there was an announcement of a new Apache Beam components transformation for Cloud AI platform, as well as TensorFlow extended components for streaming predictions on local or remote models. And something that we're going to take a look today, 5 new solutions from the anomaly and pattern detection. The, let's say, solutions with real-time AI fit in these 3 areas. Now, you remember that we approached it that it can be predictive forecasting, that you need time series, and you would approach it by using equipment maintenance. And this would be a main use case that we are going to approach. For the anomaly detection, there are 3 cases, 1 for telco, 2 for FSIs. For telco is identifying malware and detecting anomalies in traffic between senders and recipients. For FSIs is identifying currency pair on stock trades, and not only stocks, and we're going to explain it in a few seconds, as well as identifying fraudulent transactions. For the pattern recognition, it's an implementation on logistics, reducing the shrinkage by tracking packages from door to door. What I want you to understand is that all these solutions can be, let's say, approached and customized for your specific needs. So it's not something that's, let's say, quite strict in terms of usage and approach. I wanted also to show you one other idea that can be implemented, the real-time inventory management and analytics that allows you to be instrumented, organized, and get all the information analyzed as fast as possible. That starts from employees, customers, and spaces, and how to properly approach it. Definitely, there are some names of technologies there that can be used in order to properly approach the solution. So Android, Vision API, which is very important, data prep with BigQuery, as well as AutoML and demand forecasting. How this was implemented was by using in-store data like POS, inventory, RFID, based on different products, security cameras for the video data, as well as other offers and offline information that was used in order to be processed. This is a mix of both, let's say, traditional approaches by using transactional inventory data, as well as using video data in order to better detect everything that's related to patterns, how customers are behaving, what's happening to different parts of a shop and warehouse, and so on. So the idea is that you can definitely mix and put together a lot of structured and unstructured information with just a few building blocks that you can connect through simple logic. One of the new solutions is the pattern detection in video clips, and this links to the example before. This is the ingest, process, and store area. When you go to the ingest, you need the PubSub in order to get the proper real-time data, as well as cloud storage, where you will be able to store all the videos there. Now, for the videos, you will need to identify all the bits and passes like clips, as well as frames that were of interest and had to be processed. And this is something that's being addressed by the Cloud Video Intelligence API. Dataflow is used for processing, and this is one of the main processing engines. And what's important is what's happening with the information once it's being taken out from the raw data, raw videos. Everything is exported in terms of results to BigQuery, as well as to PubSub in order to be consumed as a further step. Another solution was the predictive equipment failure with images. And this is important because a lot of the knowledge of the workers does not fit only in the, let's say, structured information or some, let's say, attributes of the PCBs and so on. So it's a matter of also identifying, for instance, wrong weldings on some of the parts, as well as rotations and so on. So in this case, a similar approach was done, but it was approached on the Cloud Vision API, which means that a lot of images were being used in order to train the logic, as well as to, let's say, get the best results possible from this process. The results, the features were exported to BigQuery for further analysis, dashboarding, so anything that the organization needs as a next step. Another important thing is the anonymization identification of PII data, because more and more of the data that we're working is or can go into the sensitive and or regulation area, such as GDP or under the GDPR influence. So this needs to be properly handled. So this is an example that can be approached by everyone that's working with this kind of customer data. So cloud storage, in order to identify, to keep the data flow, and DLP as a service is used in order to get the information as much as possible to an anonymized and de-identified, so that when it's stored in BigQuery, you can no longer link it to the data there can no longer be, let's say, linked to a person, to a specific one. So it gets all the flexibility for analysis as much as possible. Again, you would have the data flow and PubSub in order to push the information, take it to a next step, and also do the processing in real time.
I'm sorry to interrupt. You have just 2 more minutes.
Sure. So I'm also going to, let's say, give you a few ideas of what can be covered here. Definitely, there are a lot of examples. We do not have time today to go through them. I would choose to, let's say, give you an idea on the stock trades, because this is linked to transactions, and it's also using TensorFlow extended in order to identify the anomaly, let's say, anomalous transactions that are processed in data flow as a final solution. How it happens? It's pretty much using accumulation, and let's say all the information is done by calculating on a rolling window. So you got a lot of KPIs that can be used in order to identify anomalous stock trades. To wrap it up, you are able to get all this information, all the use cases that I've presented today, in the cloud.google.com/dataflow page by going into the real-time AI. And I promise that there's a surprise associated to today's presentation. So for the ones that are curious enough, you will be able to go to the page of the event, and there you'll be able to, by filling in a form, have access to either, let's say, separate stages or separate lessons and events on data flow, or there's a full quest that takes you through all the process of building flows, AI, and so on in just a few hours. So I would like to thank you for your time today, and I'm going to stop sharing my screen now.
Thank you very much, Dorian. It was a very interesting talk. We also have a few questions from our attendees. So one of it is, what is the throughput that the Cloud DLP can handle? Can it handle batches, or is it going row by row for the dataset provided?
So it can approach it both. You'd be able to even take, I think you can even take can play with it in one of the quests or the sessions that you can apply for.
Okay, thank you. The next one is, why would you use Apache Beam instead of Apache Spark?
So definitely this is a long discussion. I'm not sure that I'm going to cover it properly today. So yeah, I will leave it to the experts to approach it. Definitely there are different flavors, and there's no wrong or right. from my point of view, technology is a matter of if it definitely applies to your needs or not from a business point of view. And if you would be looking on the GCP platform, you'll be able to find a lot of examples that cover, I don't know, different technologies today. And we work for our customers to find the best need that fits their, let's say, the best solution that fits their need. So there's no wrong or right or difference, complete difference in flavors in here.
Thank you very much, Dorian.